Now the next topic is appending to a file, and this is where I think the fopen scenario has a little bit of a benefit to it. If we wanted to append to a file using what we know so far, there's again two approaches. One is if we set a variable equal to the file name. We then ensure that the file exists. Now, what we could do is load the entire file. We then append our new data to that file. So here I'm appending new text to my original information, and then I'm saving it to the file. Now, when we're getting into larger files, let's say we're using a log file, and we want to log all the information for each day. Yeah, so essentially you'd be loading the entire file to write one line to it, and then saving the file again. Now, if we use the fopen command, we can. It's a little bit more efficient memory-wise. We can check if the file exists. If it exists, we'll open it with the parameter 3, which is to append. If it doesn't exist, we'll open it with the create parameter, so it'll either create it or append to it. And we use the simple fput command to add a line to it and close. So the fopen command is definitely beneficial if you're getting into larger files, like I said, for appending. So to show that, we'll just go through another example. Actually, let me copy that so I don't break the sample. So with the loading and saving to a file, so I'm going to load the entire document into a variable. I'm then going to append something to this variable and save it over the file. And again, this is a little bit inefficient because you're loading the entire file just to add one line. Let's do this. If you ever run into that scenario like I just did, I'm running the script, and basically I'm trying to access the file
Open.
sales order data out. It says it's already open. The most common reason for that is if you have it open in the Reform Designer. I've done this fairly often, so I'm not surprised.
We all have. Yeah.
Basically, opening the text file in the Reform Designer locks that file. So I'm going to use this copy of it instead for this demonstration. Now if I open this data stream, we can see down at the bottom of the file it says new data. And if I was to run the script again, let's say we change this to 2. Oh, I opened the wrong one. We can append additional lines to it. Now to use the more efficient approach, I actually need to check that the file exists first. If I was to use the append option, we could see number 3 is for append and write. I'm going to change my file name to log.txt. And So what I'm doing here is I'm specifying a file name that doesn't exist, and I'm trying to open the file to append to it. And I'm just going to write the current time. Now, because the file doesn't exist, we get this error that the unknown file handle on this line. So when we're using this fopen for append, we need to ensure that the file exists or that we use the correct number on the end of the parameters here. So if the file exists, we want to append, which is the number 3. If it doesn't exist, we want to open the file to create it, which is the number 2. Now if I step through the script, we can see the first time it goes through this line. The second time I run the script, it's then going to see the file exists and use this other open command. And looking at my file, we can see it's simply appending to this file. So if I was to run this command or run this script multiple times, it's just going to continue to append to this document.
Fantastic.
And again, this is a little bit more efficient, especially for logging, because it doesn't need to load all the information into memory. Any questions so far?
Good.
Let's see. Tricia or Vladimir?
Yeah. I'm good.
Oh, I'm okay. Thanks.
Okay. I guess let's continue. So the next thing that we have regarding files is deleting files. And what we're doing here is, again, we're specifying a file name. We're verifying that the file exists. And we then have a command here, wait file lock. Wait for file lock, basically similar to what I just saw with the text file that I had opened in Reform. The file is locked. I can't write to it. I can't delete it. I can't rename it because it's in use by another application. And this wait file lock command basically will have your script wait for that file to become available. Now you can specify for it to wait forever, or you can specify a timeout. In this case, here I have a timeout of 30 seconds. And once that file is then available, we can use the file delete command, which will delete the file. Now, when we use file delete, that data is then lost. There's really no way of getting it back. So I'd recommend, obviously, be very careful with the files that you delete here. Let's go to the script, and we'll go through a sample of this as well. And this log file that I've created, I'm basically going to try and delete this document now.
With wait file lock, is it just waiting until no one has a lock or till it can obtain a lock?
It's waiting until...
does it obtain a lock?
It doesn't actually lock the file itself. It just waits for anything else that has it locked to release it.
Okay, got it.
Okay. Now, wait file lock can also be used to create conditions. Let's say we have a timeout of 30 seconds, but within that 30 seconds, the file is never unlocked. We don't want to continue and try and delete that file because we still don't have access to it. So we can actually use wait file lock in an if statement. So what I'm going to do is, if this returns true, it's basically going to tell me that the file was unlocked. Otherwise, if it waits 30 seconds and never gets unlocked, I'm going to print this message to the screen that says the file was not unlocked. Try again. So let's step through this. And I'm currently
open the file.
Well, the first file I'm going to use is currently unlocked, so it should continue through the script without any problems. So we're going to go through here. The file is unlocked. We delete it, and we can see that my log file is no longer here. And the script continues. Now, if we were to use, let's say, I'm going to open this one in my designer to lock it. And I'm going to shorten this to 10 seconds just so we don't have to wait too long for it. Now, if I run this script, after 10 seconds, you should say that the file was not unlocked. To try again. Now, if I do this script one more time, and after I run it, I try to close the file from the designer, you can see I then see that it's unlocked, and it deletes that file. So my copy is no longer here. So wait for file lock or wait file lock, that command is very important when you're trying to access files, not only for deleting but also for reading and writing, because if something else is trying to access that document, usually you don't want to try and interfere with that. Now, I have seen some cases where maybe a file is being scanned, or depending on where the file is coming from, maybe an FTP. Some cases it may not be locked, even though something is trying to write to it every couple seconds. So you may need to put additional logic in there, depending on where the file is being created. One thing that we do sometimes is checking the file size to make sure the file has stopped growing before we try and access it. And later on during the class, we can get into that part, as that's a little bit more, I guess, advanced at this point. But essentially what we could do is we check that the file exists, we check the size of the file, and we wait a couple of seconds, check the size of the file again. If it hasn't changed in file size, we assume that the document is completely created, and then we access it as we need it. If the file size did change, we simply loop through it again and try a few seconds later. Okay, any questions on accessing files? I think we've kind of covered the entire file section so far.
Nope.
Good to go.
Okay. So I guess just to give you a little quiz, if you were creating a log file, what would be the best way to go about doing that?
I know for sure.
All right.
I don't want to monopolize the call any more than I have. Do you want me to do it?
Sure, I guess.
I mean, we just do the check to make sure that if it exists, if it doesn't exist, we create it. If it does exist, we append to it, and then do the right.
Okay. Yeah. So basically, you would use the fopen to either create or append to the existing document.
And then put string.
Yep. Exactly. Okay. Now, next, what we can talk about is strings. Strings can be very useful in how you format your information, whether it's going to be, let's say, a CSV file, maybe an XML file. We can use strings in various different places, and being able to structure them correctly can be very useful. What we're going to show here is you can see two kinds of strings here. I have my variable name, which is set equal to the string John Smith. I also have a string. You can see I have string and end string with the name of my text. So I'm going to show a little example of the difference between these two and kind of which ones are easier to use for different scenarios. Okay, so here we have a sample string. So what I'm doing first is I'm setting my variable name to John Smith. I then have two strings. One is my data, and the other one is my data 2. And you can see that they look very different. The first one uses the string command, where I have string and then string. And basically within this, I can put any information that I require, and I can structure it and format it pretty simply. You can see the first line I have says this is a line of text. I then have a second line that has his name is, and I have pipe, name, pipe. And then my third line says this is another line of text. Now, what Reform does with these pipes is anything between the two pipes is going to be replaced by the variable. So here, wherever I have these two pipes, I have the variable name. So it's actually going to populate this area within my string with John Smith. Now here I have my data 2, which is essentially the same string as this one. However, it's all on one line. I need to specify the carriage returns and the line feeds, which is I've simply made a new variable called newLine to simplify it a little bit. And again, I'm putting the name within the string. So if I print the two of them, we'll see that they're identical. However, in my opinion, the first one's much easier to manipulate and structure. So you can can see I have, I'm printing my data and my data too. So this part and this part actually look identical. However, the first portion here is much easier to change. Also, something that I didn't mention earlier that I just realized now is, just so that you know, the scripting language is not case sensitive. So you can see here,
notice that.
I have a capital N for new line, and here I have a lowercase n, and that has no effect on the script. So if I had, okay, I guess going back to the strings, if we had another piece of information, just by putting the variable between these pipes again, I can insert the current date and time. So you can see here today is in the current date and time. If I wanted to do that in this second string, it'd be a little bit more complicated. I would have to go here and say, what did I say? Today is. So I would need to append my string manually, as well as insert my new lines at the end of each line.
But you could still be updating those variables either way through the functions or go subs or whatever. It's just, you're right, a little simpler to manage, I guess, with the first. Is there a difference in speed? Like, what if you're building a big, long print output that's going to be like 5 megs or something? Is it faster to process the first way?
Not that I've noticed. I believe they should go pretty much at the same speed. The only benefit I've seen with the two different approaches is that the first one allows you to format it much easier. But if you're doing simple text, it might be easier to just say, just like I have here, name equals John Smith, instead of saying string, name, and then having John Smith on its own line, and then end string. So it's really just a personal preference and, again, readability.
Okay.
Now, normally, like the name would be underscore customer name or whatever it is in the form.
Yes, that could be done as well. So that's actually a good point. Let's say instead of hard coding it to John Smith, we can say, let's say sold to name. Now you can see his name is HGC Heavy Equipment. Just as an example of the company name. It's not really a person's name, but you can populate these strings with information from your form as well. The thing that we're going to cover with strings again is how to add them. And let's say, for instance, we have two costs. One is $10, the other one is $20. If we were to take them as strings, you can see they're within quotes, or even if we were to take them from the form, it would also be considered as string. If we tried to add them together like this, what we would get is not 30, but 1020, because it's really just putting the two strings next to each other. If we wanted to add them so that we get the total, if it's a string, we would need to put this val command around it. So you can see VAL cost A plus VAL cost B. So it's going to take cost A, which is 10, convert that into an actual number instead of text, and add that to the value of the second cost. Now, once we have that number, again, it's a number, so we need to convert that back into a piece of text if we want to use that somewhere. And to convert it back into text, we use the str command. So I guess let's do a quick example of that. I believe that was order total on here. Oh, this is still, okay, that's order total. So now all three of these are currently strings. So what I think the output should be is 1020 and then 363, etc. Now that's because using this for strings is going to simply put the strings next to each other. And you can see it's doing exactly that. We have, instead of having the total of 393, we're getting a string that has all of the numbers on them. Now, if we wanted to actually add those, we would have to say val. And this is going to add the value of those strings instead of the strings themselves. Now, since we're adding these values, again, total cost is then going to be a number, and since we want to display that to the screen, or if we want to put it on the form, we should make it text again by putting the str command around it. Oh, actually, that was correct. So here we have the order total is 363, plus 20 plus 10 is 393. Now, in some cases, you may be able to not do it without, or you may be able to remove the str, and it'll still work. However, it's best to make sure that you put str around it, because in some scenarios, it may cause the script to break. Now, let's say, for instance, we change this to text instead of a number. You can see it no longer adds that value to it. So instead it has 363 plus 10, and this cost for B is no longer incorporated into the total cost. But if you wanted to check for that type of scenario, there's a command called isNum. So you could say if so I can check that they're all numbers before I add them. So you can see it, because I checked that cost B is a number, and since it's not true, it's going to go to the second part of my if statement and display that they're not numbers. Now if I change this back to 20, it should display the total.
Can you store the variables as numbers, like cost A equals val brackets 10?
Yes. So if I was to do it this way, I could then, let's say, I don't need the val in here anymore because we've already converted to a number. And I can simply add them and convert it into a string.
Cool.
Which again gives us the same result of 393. And if we were to have a decimal in there, it should also continue using that as well.
Right.
So, yeah, depending on what's being done, whether you're adding or saving text, using val or str to convert your variables is very important.